So hello everyone, in this video we're going to talk about how to prepare an interior for lighting setup. Now you don't have to worry, we'll be coming back to this topic in the upcoming videos. And today I'm just going to give you some general tips, and without further ado, let's get started. So when working in Corona or Vray, we can use preset render settings. Now this is how it's done. You go ahead and press F10 on your keyboard to open render setup window, and then in the preset field, click load preset. I've prepared 4 presets in total. For Corona, we have a file with fast settings for preview or lighting setup, and setting for the final render. The same for V-Ray, fast settings and final settings. Now you can change these presets to meet your needs, but using ready-made presets you can save a lot of time setting up your render. Okay, for color selection, I'm going to use Corona color picker, and it looks like this. It's a bit different from the standard tool you might be used to. It's so that you know why my color picker looks slightly different from yours. You can enable this color picker if you want. To do this, you need to have Corona installed on your computer. And next you go to Customize and to Preferences, and then you go to the General tab and find Color Selector. Select Corona Improved Picker and click OK. Now I'm not sure if it will be enabled right away. You might need to restart 3ds Max. Okay, now let's focus on our scene. So as you can see, we have an entire apartment here with different rooms and spaces. But usually we create an individual scene for each room or space on the condition that there are no openings between them. Here, for example, there's an open door between the living room and the dining area. In this case, we can close the door and work with each scene individually. Or if we have the door open, it will be one single scene. Now, I hope that makes sense. That's pretty much self-explanatory. If an interior has an opening, like a doorway, through which you can see another interior, they make a single scene. So to avoid cases like this, it's best to create separate scenes for each interior, because it strongly affects 3D optimization and render speed and your performance as a whole. Now it's best to work with each scene separately. It's faster and easier to work this way, especially when you make adjustments and corrections. So the files attached to this video lesson contain the entire apartment as a single scene. It's called main scene, as well as a separate scenes for each interior, including a bedroom, a dining area, and a living room. There's a hallway, bathroom, and kitchen. Each interior has its individual scene. That's very convenient. Now let's talk about optimization, and let's switch to camera view and take a look at the living room. When creating a scene, you should split it into layers. One layer for furniture and one layer for decorations and small elements. Also one layer for the 3D model of the room, and so on. Now some visualizers hide cameras in a separate layer. Now I don't do that personally, but when it comes to decorations, they must all be added in a separate layer. That's because small objects like vases, figurines, flowers, and things like that, all of this slows down the render big time, especially at the preparation stage and initial lighting setup stage. So the rule of thumb is this: If an object won't affect the lighting in any way, and I mean won't be casting big shadows, you can go ahead and hide it in the decorations layer. Here, for example, we have vases and boxes and objects like that, and when we unhide these objects before the final render, they won't affect the lighting in any way. Take a look at this fluffy rug. It's made of a huge number of details, and it will be slowing down our render. That's why we need to hide it before setting up lighting. So once you've filled your interior with larger pieces of furniture, you can go ahead and set up lighting. There are some exceptions though. Here, for example, we have a large plant, and we should keep it because its leaves will be casting shadows and creating a light and shadow pattern. And this means that you need to make an individual decision for each individual object. I also hid moldings in this layer. If you have a classic interior, small things like this increase render time dramatically. So it's best to hide them in a separate layer. They won't affect the lighting in our scene in any major way. So just make sure to keep that in mind. Alright, and so now let's focus on the curtains. Should we keep them or should we hide them? Well, it's best to hide them in the decorations layer or in a separate layer even. Before setting up lighting, we need to empty the room. And only then, once the lighting has been set up, we can then unhide curtains and things like that. We'll have a whole video dedicated to curtains, but for now, just pretend they're not there. So we'll talk about it later. All right. So we have curtains in our scene. We need to hide them in a layer and then set up beautiful lighting. And then we can bring back the curtains and do lighting correction. Because it's not uncommon that beginning visualizers leave curtains, and the curtains are blocking the light from the window. And visualizers then wonder why they can't set up proper lighting. So before setting up lighting, make sure nothing is stopping the exterior light from getting inside the interior. Now let's say a few words about window glass. If we're using clay material in the override mode, and we'll talk about that in the next video, well, that stops the light from getting inside. And this can be very confusing. So this is what you should do. If you have small-sized windows, there probably won't be any reflections in the glass. Most likely. This means that you don't need the glass at all. So you can simply remove the window glass because it doesn't affect the render in any way. You can even tell if the windows are glazed or not. To see if the windows in your interior are glazed, you need to do the following. So click Default Shading and switch to Clay mode. See? This geometry here, which means the windows are glazed. Remember that window glass with clay material applied to it may be blocking the light. In this case, we need to use the exclude option. And I'll show it to you how it's done further on in the course. And so finally, I'd like to talk about poly count. Now, poly count shows the number of polygons in the scene. So if I press 7 and see the total number of polygons that our scene has, it often happens that some high poly object is making the scene too heavy. It becomes especially apparent during lighting setup. So make sure to keep the number of polygons at a reasonable level. All right. And one more thing. So suppose you want to find a high poly object that's slowing down your render. This is how you do it. You simply select by name, And you see there's a column called faces. And if you don't have it by default, you need to add it. So to add it, you do a right mouse click and choose replace column and select faces. Next, you need to sort the objects by the number of polygons. So you click the column and sort the objects in increasing or decreasing order. At the bottom of the list, you'll find that very same rug with a huge number of polygons. There it is. So we go to object properties and see that it has 2.5 million polygons. If you can hide a high poly object before a lighting setup, or you don't want to do that, try doing the following. You need to change its display mode to display as box. Go to object properties and put a check against display as box. But the thing is, it won't make your life easier when you're setting up lighting. That's why it's best to hide objects like this. All right. Okay, so that's it for today's video, folks. At the end of the course, I'm going to give you specific tips on how to optimize your scene and get things done faster and easier. All right, let's talk about cameras. What cameras should you use? And this course doesn't cover composition and camera view setup, but I still would like to give you a few tips on this matter. So feel free to use any camera that you feel comfortable using, basically. There's a standard camera, standard physical camera. There is V-Ray camera. And there's Corona camera, and all of them have the same settings. There's no such rule that says you must use Corona camera when working in Corona or use V-Ray camera when working in V-Ray. They all have identical settings, basically. So let's take a look at Corona camera, and let's switch to camera selection mode first. And here you can set exposure and field of view. So basically, field of view is the width of the scene as perceived by the camera. The zoom factor regulates focal length. ISO shows how strongly the camera responds to light. F-stop as aperture. So all of these settings define the brightness of your scene. And you can change exposure either via frame buffer and Corona V-Ray or via camera settings. The choice is yours. If you have a complex interior, and I mean if you have multiple spaces, some lighter and some darker, like this corridor here, then you should be using several cameras. You need to set up each individually, and they must have different exposures. But if you have just only one enclosed space, it doesn't really matter which camera you're using. As for me, I tend to stick with the standard camera that has no settings at all. So you can apply the camera correction modifier, but that's it. With V-Ray, it's all the same. Here we have film gate, it's the angle of view. There's aperture settings like for the Corona camera. ISO, f number, and shutter speed. Now there's nothing more to it. The rest of the settings are identical for all cameras, although sometimes they can be found in different tabs and selections. But that's okay. Also, there's depth of field, there's motion blur and white balance, and these are identical to the general settings in the frame buffer that we're gonna see in the upcoming videos. So what other settings do all these cameras share? First, there's automatic vertical tilt. If your camera is tilted and you need to adjust the vertical to make them parallel, you simply check this box, automatic vertical tilt. and the verticals will become parallel. Corona has the same setting. See? We'll go to the tilt and shift tab and check automatic vertical tilt. And if we move the camera further away, we need to use a setting called clipping. We need to crop everything in front of the camera that we don't need so that we can render the entire interior and not just the wall. All of these cameras also have clipping settings. For Corona camera, it's environment and clipping tab. And we check the enable box and enter the near and far values. Like so. So the near indicates at what distance from the camera the clipping starts, and far indicates where it ends. If we talk about V-Ray camera, it's pretty much the same. We scroll down, we find the environment and clipping tab and check clipping option. Say we need to clip the scene by 2 meters. So we enter 200 here, and we've got this cutting plane. Let's make it smaller. And next we enter the value for far environment range. It needs to go beyond the interior so that we don't cut off anything important. For the standard target camera, it works the same way. It has clipping settings, and we check clip manually box. Near clip is 100 centimeters, and far clip should go beyond the interior. The standard physical camera works the same way, so it doesn't matter which camera you use, basically. All right. Now, here's one more thing. Once you've found the right view for your camera, you should fix it in place. When shifting around objects in the scene, you might accidentally shift the camera. To avoid that, you need to do the following. Simply click Select Camera, and it's best to select that with the target. So we switch to camera selection mode and select our camera together with the target. And then you simply go to the hierarchy tab and click the link info button and check all the boxes. And this way you won't have to worry about accidentally shifting the camera. All right. Now let's switch to the camera view and try to shift it. See? We can't do that because the camera is locked in place, and it will save you a lot of trouble. The gray color that we use in our renders is called clay material. So let's find out why it's so important to use it. When setting up interior lighting, you need to know the color and brightness of light in your interior. And if you choose to set up lighting in an interior with materials, they will act as a distraction. You won't be able to tell what the actual light in your scene looks like, and as a result, you're very likely to set up the lighting wrong. Materials affect what interior looks like. Each material has its color, it's got its shade, and that may confuse during lighting setup. So that's why you should always use clay material during lighting setup. This is very important. So look, this is a living room, and before we get down to lighting setup, we need to assign a clay material in Corona. So to do that, we press F10 as usual. We open render setup window. Then we make sure that we have Corona selected as our current renderer. And then we go to scene tab and check MTL override. This slot must be empty. Let's reset settings to avoid confusion. Okay, so we check MTL override, then click none, and select Corona Physical MTL. If you're using an older Corona version, like Corona 5 for example, this material will probably be called Corona MTL. Doesn't matter though. To create basic light, we're gonna use a single map called wide synthetic. So this is basically it's a wide environment light. and we don't need anything more for now. So next we're going to switch to this view. Okay. The current render view is perspective, but we need this camera view. So we unlock the perspective view, and Corona automatically switches the camera view to the one that we need. And then we just lock it. And now when we make changes in the scene, our interactive render won't be switching between the windows. So that's very convenient. All right, let's start it. The render has started, but the image is still black. Nothing's happening there. Why is that? Well, that's because the clay material has been assigned everywhere in the scene, including the windows. So we can fix this problem in two ways. Method number one, we can exclude window glass from override option. And there are two ways to do that. The first one is preserve option. If we click this button, Corona will identify glass material and exclude it from the override option. So we'll put a check against preserve glass materials. But here's one important thing though. You need to set up and assign a glass material, otherwise it won't work. In the meanwhile, we can already make out a window opening in our render. So this means that we've done everything right. Now, another way to do this is to select the glass and click the plus icon here, add the glass to exclude list. See, one object excluded. Done. And now let's see method number two. If you have small windows and you don't care about glass reflections, which is most often the case, you can just delete the glass object altogether. Just delete and forget about it. Okay, now we need to set up brightness, and since we're using a standard physical camera, we can change the simple exposure and the frame buffer. So we need to adjust it in the camera settings. Now pay attention to this. If you're using a physical camera, this parameter will be unavailable. So we select our current camera, and next we go to the Modify tab and find the exposure settings. And we can either change ISO, its sensitivity level, or set up the standard exposure value, EV. That's currently at 6, so let's bring it down to 0. And our image has turned brighter. Now, here's a common question. How do we know what the right exposure value is? What is the optimal ratio of environment light brightness and material brightness? So let's find out. We open the material editor window. We also open render setup. And now we need to take the material that we used for the override option and drag it to material editor. So we click this Corona Physical MTL, and while keeping the left button pressed, drag it to material editor as instance. So always copy it as instance, so that when we're making changes in material editor, the same changes apply in render setup. Okay, here's our material. Next, we'll do a right mouse click on the material and select Open Preview Window. So we have this preview sample, and let's make this ball bigger. And we need to compare the sample with our current render. We see that at the moment it's too dark. The material in our render should match the color of the sample as a general rule. And that's very simple. To achieve that, you simply need to adjust the exposure. And let's put it to -2. Or maybe -4 even. You know what? Actually, I think -5 will do just fine. Okay, so we've adjusted the brightness, and now we go to the Performance tab and uncheck Fast Preview Denoise to get rid of this blurriness. And as you can see, we already have some very basic light setup in our scene. All objects in our scene have a clay material assigned to them, and we can proceed to setting up proper lighting. So if you have a darker render with dark walls, dark ceiling, and floor, and so on. Now, I'm not talking about situations when you have just one dark wall, or when the walls are dark while the rest of the interior is light. It's not considered a dark interior. If most of the materials you're using are really dark, you can correct the color of clay material in order to set up correct lighting. So the default value is at 186. If you have a dark interior, you can decrease it to say 80 to achieve a darker color. This is what a dark interior with dark materials look like. So keep that in mind. Don't try to decrease this value all the way to 20 or 10, because your interior will turn black and you won't be able to set up lighting at all. Okay? So for standard light materials, the optimal value is around 180 or maybe 185. And once you've set up this value, you can adjust the brightness based on the previous sample. So when you turn the materials back on, you probably have to adjust the exposure, but that's totally fine. Today we're going to see how to use clay material when setting up lighting in V-Ray. I have an identical video for Corona. It's the same thing, so you can check that out if you want. Alright, now let's see how to do the same thing in V-Ray. So to set up correct interior lighting without being distracted by reflections, materials, and other stuff, you need to use clay material. Now, if lighting looks good with clay material, it will look even better with other materials once you've assigned them. Alright, now, so here is our living room. And I've deleted glass and curtains. There are only window frames left. So let's do some preparation work for starters. We'll select V-Ray 6 as our current renderer. And next, we'll create a V-Ray light and put it outside the scene. It's a dome light. So why are we using this type of light? Because we want to achieve a simple white light coming through the windows. In Corona, we would turn on the environment option, but in V-Ray, we'll create a dome light to speed up our render. Now select current camera. I'm using a standard physical camera. It doesn't matter much which camera you use. Make sure to check out my video on cameras, by the way. Okay, next let's open the render setup window. And before starting interactive, let's assign clay material to all objects and surfaces. So how do we usually do that? Well, usually you go to Material Editor, pick a clay material, and assign it to all objects. But that's not the best way to do it. Both in V-Ray and in Corona, we have a special override option, and you should be using that instead. So we go to Render Setup. V-Ray has a whole bunch of settings. Don't be scared though. Then we go to V-Ray, go to Global Switches, and check the box against MTL Override Settings. And then we click No Matte and look for V-Ray MTL. So select it with a double click, and then make sure the physical camera that we're using for our render is active. So we can lock the current viewport like this. And then we go to frame buffer and click show last VFB. There we go. And then we click this little teapot icon to start interactive render. There it goes. The scene is too bright, as you can see right away. It's overexposed, which means that we need to adjust our camera. So we click select camera, and each camera, except for the most standard one, has an exposure setting. Target EV stands at -5, and we'll bring that to 0. See, the brightness has gone down. Let's increase it to 5 though. Now, how do you know when you got a proper exposure? Well, that's very easy. We just need to compare the brightness against the material preview. So in order to do that, you open Material Editor and Render Setup. Remember how we added the V-Ray MTL here. So we just drag it to Material Editor and copy it as instance. Okay, and here's our material. We'll do a right mouse click on the material and select Open Preview Window. And this is our preview ball. The brightness in our scene must match that of the ball. It's pretty easy, right? So let's increase target AV to 6. Actually, let's bring it down to 4. Okay, good. Now the brightness is okay. See these highlighted areas on the window? Well, we can easily get rid of them during post-editing. You might need to revisit my video on frame buffer and Corona to freshen up your memory, but here we simply here we add a new exposure layer and reduce the highlight burn parameter. See, the highlights have gone away, and we can also adjust exposure and contrast if we want. And that's the result we need to achieve when setting up basic lighting. In all of our videos on lighting setup, we will only be using clay material. And here's one more thing regarding glass. Here in this scene, we have no glass in the windows. But if you have glass windows in your scene, you can exclude glass in render settings. You can do that both in V-Ray and Corona. You click MTL Override Settings and select the things we want to exclude from Override command. Select Refraction and Reflection, all right? Or we can do that in a different way. We can click Exclude, find glass in the list of objects, and add it here. And that's it. In this case, we don't have to do that because there's no glass in this particular scene. So always keep that in mind. Before we move on, let's say a few words about albedo, because it's a very important topic. Albedo strongly affects render speed. And albedo is the reflecting power of a surface, you could say. Now, it shows the ability of a surface to reflect light. So the brighter the surface, the better it reflects light. So why albedo is so important to us? Well, that's because graphic engines take albedo into consideration. I'm not going to bore you with albedo values for different materials. Now, some students take this kind of information too seriously and start to overcomplicate things, trying to achieve precise albedo values. Well, there's absolutely no need to do that. So what you should do is you should keep in mind that there's such parameter as albedo, and that it shows how light a certain material is. So for example, an A4 paper sheet has the albedo of around 0.8. Now you shouldn't make your materials too light. You shouldn't make them too white, because otherwise the graphic engine will take forever rendering your scene. You'll have to deal with artifacts, highlights, points, and things like that. The graphic engine will take too long getting rid of all of that noise. So don't underestimate the importance of albedo. This applies not only to materials, but also to textures. So suppose you have a white texture. It can be white pages of a magazine lying on a table. In that case, you would need to decrease its albedo. So let's see a practical example in Corona Render. So here we have a clay material here. The current color value is at 186. And if we increase it by 100%, to 255, the render will become too bright, too highlighted. And this isn't the way it should be. You should always decrease the albedo. So what color value should you choose? For a white material, the optimal color value should be around 200, 220 tops. Or you can change the albedo value here. The whitest material should have the albedo of no more than 0.8. So the higher values are a no-go. So suppose you assign a texture to your material and now you want to adjust its albedo. So this is how you do it. You go to base layer settings and decrease level value. Suppose you have a white texture and its albedo is at 1. See, this scene is too white. We reduce the level value to 0.7. And the albedo has improved. See? That's pretty much it about albedo. So you can check the albedo value using a special render element. We haven't covered render elements yet, but I'll tell you anyway. So in a tab called Render Elements, you can click Add button and find See Shading Albedo and click OK. And then we restart our render, and here in the drop-down list, you're going to get a new albedo element. I already had it added. So then I simply click albedo element, and if the image is gray, then the albedo is fine. So let's create a material with an incorrect albedo value. So suppose a beginning visualizer set it up wrong, and we assign this material to the table. So we have the override option enabled. So we need to exclude the table from the override option. So we click the plus icon here and add the table to exclude list. See? Now it's turned red. So if albedo of a material is set up incorrectly, this render element will be highlighted. So we'll switch to beauty pass element, and the table doesn't look good either. So I've talked about override materials in one of the previous videos, and you can revisit it if you need to refresh your memory. But to get the albedo right, your override material should have the level value at 1 and the color value at around 180. If an object has an incorrect albedo, it will start showing points, artifacts, and stuff like that. And if the table had a light source on it, it would look even worse. So make sure to always set up albedo properly. Alright, now let's see how albedo works in V-Ray. Now it may seem to you that this parameter is more relevant for Corona users, but that's not true. V-Ray users also need to pay attention to albedo and avoid making their materials too bright. So let's go ahead and make an experiment. Let's replace the current override material with a white material. See? There are artifacts. And this is what makes the scene look bleached. So if you're using V-Ray, make sure to pay close attention to albedo as well. So as far as I know, there's no way to check the current albedo value in V-Ray. But if you happen to know how to do that, please let me know. If you have an override material, a wall material for example, its albedo shouldn't exceed 255. So you should go for a lower value. If your override material is white, once again it can be a wall material. its albedo shouldn't exceed 0.7 or 0.8 as a general rule. Okay, so that's all for today. See you in the next video. Alright, the next tool in our disposal is Corona Sky. And Corona Sky is a map, and it's a map that illuminates the interior with scattered light from the windows. Both in Corona and Vray, Sky is the main light source in the interior. The rest of the light typically comes from accent lights. Sky is the key source of light. In today's video, we're gonna see the most basic sun-sky model for interior lighting. We'll go through the Corona Sky parameters and we'll create the sun-sky light model. So let's get started. So I have Corona selected as the current renderer. I'm going to assign the clay material first real quick. Enable MTL override, click none, and select Corona physical MTL. Then preserve and check preserve glass materials because we have windows in our scene and we want a light to get through them inside our interior. You can go back to my video on clay material if you need to refresh your memory. But we have a parameter called scene environment. And this is the fill light, the scattered light coming from the window. Corona will be taking all light-related information from these 3ds Max settings. So press 8 on the keyboard to open Environment and Effects window, and here you should have, you need to add a map to the None slot, or you can select Single Map and add a map here. You can use any of these two methods. I'm not going to change anything for now. Now we'll just create a sun that will be shining inside the interior. So we'll go to Corona Lights and select Corona Sun. We'll direct the sunlight inside the interior so that it illuminates the wall opposite to the camera. Now, if you remember well the theoretical part that we've covered earlier, you should know that to be able to correctly identify the shapes of objects, we need to see their parts that are lit, shadowed parts and parts lying in penumbra shadow. So that's why it's best when a light source is at around 90 degrees to the camera. Our camera is here, so we direct the sunlight onto the opposite wall at around 45 degrees. Okay, and let's start our interactive render. There we go. And now we can set up our sun. Its intensity is at 0, and that's why we don't see it. So let's increase the intensity to 1. Now we'll go to Performance tab and disable Fast Preview Denoise to be able to see small details. And so now we can proceed to setting up the fill light. But let's turn off the sun for now. We'll simply uncheck this on box. And this makes the scene go dark again. So now let's create Corona Sky. And Corona Sky is a map, as I've said earlier. So to do that, we need to open Material Editor window, and then go to Corona Sky and drag the sky map to Material Editor. And again, we press 8 to open the Environment and Effects window. And next we drag and drop Corona Sky to this slot as instance. Make sure to copy it as instance so that when we change the sky parameters in Material Editor, they change in the environment settings as well. Alternatively, you can enable a single map and link Corona Sky to this slot. So feel free to use either method. See which one you like best. Now, let's switch back to 3ds Max settings. And let's take a look at interactive render. And we can already see the light coming from Corona Sky. Now let's set up exposure. Now, remember what I told about the dynamic range in the beginning of this course. The light outside the interior is white, and that's absolutely normal because the environment should always be much brighter than the interior, because the environment is our key source of light. If we keep decreasing the exposure, then we're going to see the blue sky at a certain point. But in that case, the interior will turn dark. So make sure to keep that in mind, especially when setting up the background. We'll talk about it later. And for now, let's see the Corona sky settings. But first we need to tie in the sky and the sun. So once we do this, the position of the sun will be affecting the sky map. We can select the automatic mode, but it doesn't always work. See, there's a message that says no suitable sun found. Now, I don't know why it says so exactly, but we can switch to the manual mode and click none and select our current sun. And nothing has changed. That's because our sun is turned off. See? And now when we turn it back on, the light now has become totally different. Now we have bright daylight. But we want to achieve a more neutral, more natural lighting, like in our references. You can see here the light has a clear direction. There are shadows, but at the same time, there's hardly any direct sunlight. So this is basically the most commonly used lighting scheme, and we're going to stick to it and we're going to try to imitate it. So our task is to tie in the sky, which is our fill light, and the sun in a way that the skylight is affected by the position of the sun itself. So at the same time, we need to make the sunlight less bright. This is how we achieve that. See, now that I lower the sun, everything changes. The light from the sky has changed. It's more yellow now. The sunlight has turned more orange. Now let's turn off the sun just for now, and let's set its intensity to 0 instead. See what we get. By raising the sun, we get a colder light. It's more like daylight now. And by lowering it down, we get an evening light. See, this is natural. So let's put it around 45 degrees and direct it onto this wall. This wall right here. So we see that now our sky and our sun mutually affect one another. I mean, the sun affects the sky. And now, let's try to set up a realistic lighting by adjusting some parameters. So first of all, we need to raise the exposure because our interior is rather dark. So let's increase it to 2. The light has a cold shade. Let's take a look at the parameters. First comes sky model. Here we have a relatively new model, PRG Clear Sky. V-Ray has it too, if I'm not mistaken. It's the most realistic daylight model. There are other models as well. You may like them better. There's Pretham, for example. It has a colder light. There's Hosek. Its light is closer to the cyan color. Anyway, all of these models are more or less the same, so you can pick the model you like best. As for me, I'll go for PRG. There's also a Rava Fake. We'll talk about it in a dedicated video, and we're going to use it to set up a beautiful light. Okay, so we pick PRG. Next we have intensity. We can set it to 0.1, and then the skylight will be very dim. Or we can increase it to 10 or 5, and the light will turn very bright. But of course we can adjust the brightness of the light by changing its intensity, although I prefer to stick with the default value and change it only if that's necessary. To set up brightness of your image, you need to adjust exposure. You do this either in the frame buffer or in the camera settings. That is, if the camera allows you to set up exposure. Then we have turbidity. Now, that's a cold blue shade of the sky. And the higher turbidity value, the more particles there are in the sky. The light is more scattered, and therefore it looks less cold. So let's set turbidity to 10. And we've got a neutral, an almost black and white light, like in the references. Next, we have fake horizon blur. So by changing this setting, we can adjust blurriness, softness of our image. And if we set it to 0, we get a harsh sort of light. It's pretty rare though. For a softer light that shines in different directions, we'll go for 2 or 3. For improved model of PRG sky, there's a parameter called altitude. Its default value is at 0, which means 0 meters above sea level. And as you probably have guessed already, the altitude affects the shade of light. But it does it only slightly, so I wouldn't spend too much time adjusting this parameter. So next we have a volume effect. We'll skip it for now. Here in this section we tied in the sun and the sky. So the next parameter we should pay attention to is ground. Now remember what we learned in one of the past lessons. The light outside is re-reflected from the ground. It gets inside through the windows and it illuminates the ceiling. To illuminate the ceiling more intensely, we increase the ground color value. See? And now we see that the ceiling is getting more light. Now, let's take a look at the opposite situation. If the ceiling is too highlighted, we reduce ground color value. Also, there's an option called affected by sky. Now, pay attention to it because it affects the brightness of the ground color. You can check this box or you can leave it blank. The choice is yours, basically. And, well, I think that's pretty much it. Clouds parameters are more for exterior renders when we create clouds in the background. So we don't need these parameters for interior visualization. And finally, Rava fake model. We'll cover it in one of our upcoming videos. Okay, so this is the image that we've got. If you see that your sky has a wrong shade or shades, you can do the following. You'll find a map called Corona Color Correct. And what you do is you drag it to Material Editor. And then you link the sky map to Color Correct. Also, you install Color Correct in the environment map slot as instance. And this is how you make your sky colorless. So let's go ahead and create a stronger shade to make the effect more visible. Something like this. Now, suppose you're okay with the direction of shadows, how soft they are, and so on, but you don't really like the color. So this is how you fix that. You link the sky map to Color Correct, and then you go to Color Correct settings and set saturation to -1. So that makes the map become black and white, and you get a neutral light. If you want your sky to keep a slight shade, you can set saturation to -0.5. And in that case, a trace of the shade will remain. Alright, so summing up, to create basic daylight when the sun is shining through the windows, but not too bright, you can use the sun-sky model. So you basically tie in the sun and the sky, and you direct the sunlight onto the wall opposite to the camera, between the windows. Let's try to imitate lighting in these references. Okay, so we put the sun, and now let's go ahead and reduce the exposure to 1. Now, remember the previous sample with override material that we saw in one of the previous lessons. So we need to achieve the same color brightness as in the sample. So I remember its brightness from the memory, so now let's just imitate this light and shadow pattern. But first, we need to make our sun bright. The intensity is currently at 0, and we're gonna increase it little by little, and we'll start with 0.1 value. Here we already have light and shadows, and let's increase intensity to 1 to make the pattern more visible. And we'll direct the light onto the lamp and the sideboard there. Now let's try to find an interesting pattern. Alright, something like that. The sun is now shining too bright. We decrease its intensity to 0.1. And the sunspots are too orange though. There's no such thing in the reference, as you can see. So let's change the color mode to direct input, for example. The current color is white. Also, let's increase the size of our sun to 32. As a result, we get a soft, blurry, scattered sunlight that looks like the light from the sky. Now, you may think there is no direct sunlight in the scene, but there actually is. By directing the sun where we want it to be, we can create the light shadow pattern that we need. So, let's go ahead and experiment a little more, trying to create a better pattern. Alright, so we've achieved contrasting daylight. It's neutral and it's not too bright. It's kind of in the sweet spot. We can increase contrast a little bit, and this is how we set up basic daylight. Vray Sky is the main source of light in the interior. So let's find out how it works. Now, to set up neutral basic light, you're gonna need both V-Ray Sun and V-Ray Sky. And it all works just like in Corona, but there are some minor differences, however. So let's see. Now I have V-Ray selected as current renderer, and the first thing we need to do is to create a V-Ray dome. So for that, we'll click Create, we'll go to Lights, V-Ray Light, and then we put it somewhere outside our scene. Next, we'll go to V-Ray Light Settings. Multiplier is currently at 1, so we're going to stick with this value for now. The on box is checked, as you can see, and we make sure it's a spherical dome, and the alpha option is disabled. So next we switch to our camera by clicking Select Camera. Now we can start interactive render, and in the V-Ray tab we click Show Last VFB. Then we click this teapot icon and start the render. So this is the light that we currently have. we need to make sure there are no other lights in the scene. So to do that, we select V-Ray Dome and uncheck On Box. See, we don't have any other lights in the scene. Before lighting setup, you need to make sure there are no other lights in your interior. It's very important. All right, so we turn on V-Ray Dome back on, and now we need to adjust exposure in the camera settings. We're using physical camera. You can use V-Ray camera, it doesn't matter. So we click select camera. In the exposure tab, there's parameter called target. It's currently at 4, we'll make it 3. Actually, let's try 6. This is our current default light. Here in the frame buffer, we have exposure that's already set up. You can delete it. We're gonna set it up. We're gonna set up everything from scratch. To correctly set up lighting using V-Ray Sun and V-Ray Sky, we need to add V-Ray Sun to our scene, first of all. So we'll go to Lights and choose V-Ray Sun, and then simply direct the sun through the windows. There's a prompt message asking if we want to add V-Ray Sky environment map, so we click no. We're going to do it manually. Okay, so we put the sun in a way that it shines through the windows. And we see that our sun is shining very bright, very intensely. So let's set its intensity to 0 for now. Or even better, let's disable it altogether. All right, so why is it that we add the sun in the first place? Well, we need to create a beam of directional light coming inside the interior. Thing is, the sun heavily affects the sky. The part of the sky where the sun is always looks brighter. So let's see what it means. So we open Material Editor window, select V-Ray Sky Map, and then simply drag V-Ray Sky to Material Editor. Then enable it by putting a check against Specify Sun node. And then goes the sunlight setting. So go ahead and click the Node button and then click our sun. Now we need to link V-Ray Sky to V-Ray Dome. If, instead of using V-Ray Dome, we install V-Ray Sky as an environment map, the rendering process would take forever because of all that noise. That's why I should always be using V-Ray Dome. V-Ray Dome is a semi-sphere, you could say. It's the light surrounding our scene. So we can add it as a texture map by clicking this No Map button. We take V-Ray Dome and drag it to the No Map slot as instance. Make sure to make it instance so that when you change sky parameters in Material Editor, they change in the dome settings as well. See, the light has changed completely. That's because we now have V-Ray Sky. So now we need to adjust the exposure and the camera settings. We're raising it. Let's make it 10. Let's make it 10 for now. Now take a look over here. When we change the position of our sun, the light changes as well. And if we lower the sun, the light turns warmer, orangey kind of. If we raise it higher, it grows colder. So it's all just like in real life. When the sun is in the zenith position, its light is colder, it's harsher, it's clearer. And if we lower it down, we get sunset lighting. And this is how we can create a very specific light shadow pattern. Now, let's position our sun at around 45 degrees to the ground, direct it inside the interior and onto the wall. Now, pay attention to the fact that we don't have direct sunlight here. What we need is a soft, neutral light with soft shadows. Something like in this image. It has contrasting light with directional shadows, and let's try to imitate that. But first, we'll take a look at the V-Ray Sky settings. So we open Material Editor, and here we're already tied in the sky and the sun. And so next we have a parameter called turbidity. Its default value is at 2.5, and we can make it 10 to achieve a more neutral light. Turbidity is the degree to which light is scattered when coming through the clouds, through the atmosphere. So the lower the turbidity value, the colder the light. Right now our scene is too white, so we need to do some post-correction. Plus we have strong highlights on the window frames. So we add the exposure settings and lower highlight burn. At the same time we increase the contrast a little bit, and this is what we've got as a result. Let's put turbidity to 20 or 30. Doesn't affect the light too much. Ozone also affects the shade of light, but not in any major way. So you can probably skip it altogether. All right, next we have intensity multiplier. We can decrease it to 0.5, for example, and this makes the image become less bright. If we raise it to 2, the fill light becomes brighter. But I recommend sticking with the default value. If you need to change the exposure, you should do that in the camera settings or here in the exposure settings. So you can either increase or decrease the exposure depending on the effect that you want to achieve. So make sure to use the preview sample ball as a reference. So next we need to pick a sky model. Here we have PRG, just like in Corona. There's also HOSEC, but as you can see, we need to adjust the brightness for it. Overcast model imitates overcast lighting. Clear model has some pretty crazy colors. And finally, there's Pretham. We have it in Corona as well. This model is affected by the position of the sun, if I'm not mistaken. See? When we lower it down, we get a bluish shade, and then we raise it up, and it turns orange. So I recommend using PRG model. It has the most natural light. Next goes ground albedo. We use it to increase or reduce highlights on the ceiling. And as I've said in the theoretical part of this course, it's the light that reflects from the ground and illuminates the ceiling. And if we make it wider, the ceiling will become more brightly illuminated. Now the opposite situation. If the ceiling has highlights, we can make the light dark, almost black. So let's go back to the default color. All right, next we have the parameter called horizon offset. We can raise it or lower. We can lower the horizon, but it will be barely affecting the light. So to achieve a neutral color, like in this image here, we can do the following. We can link the sky to the to color correction map. And just like we did in Corona, we click General, we'll go to Color Correction and drag the map to Material Editor, and then we'll link V-Ray Sky to Color Correction. And at the same time, we need to link Color Correction to V-Ray Dome. Here, we drag Color Correction to this map slot as instance. And next we go to the color correction settings and decrease saturation. And this is what gives us a more neutral, more subtle kind of light. So now we can raise our sun and direct it here onto the wall, just like in our reference. Now, what should you do if you want to make the floor or the walls in your scene look brighter? Now, take a look at our current image. As you can see, the contrast is alright. Shadows have a direction, everything looks okay. Except for the floor, maybe. Now, what about the floor? Our floor is not as bright as in the reference, so let's enable the sun. The scene is too highlighted, so we reduce intensity to 0.1. It makes the sun less bright. But its shade is something between yellow and orange, so let's select override as our color mode. Filter color is white, and then we change size multiplier to 32 to get blurry sunlight. We can direct the beam of sunlight through the windows, illuminating the areas that we want. The floor, for example. So we've achieved neutral kind of light. So keep in mind that sun in both V-Ray and Corona is just a source of light. It's not like the star that illuminates our planet in real life. We can resize it, we can change its color, direction of the light, and sometimes visualizers create several suns shining through different windows to illuminate certain parts of the interior. We'll dive deeper into that when we're going to be talking about fake lights. So to set a basic daylight, we tied in V-Ray Sun and V-Ray Sky. And this is the light that we have set up. It's all very simple. You need to create V-Ray Dome and V-Ray Sky. V-Ray Dome either through the color correction map or directly, and then adjust it from there. Now here's another thing. You can first find the right light shadow pattern and only then enable the fill light. And I've talked about that in the Corona video. So this is how we do that in V-Ray. We turn off V-Ray Dome. The only light source left is V-Ray Sun. And then we direct the beam of sunlight inside the interior, trying to find an interesting light shadow pattern to create beautiful shadows. And you can also adjust brightness if necessary, like this for example. You can use the reference. Here the sun is shining at around 45 degrees, but we can't use the same angle in our scene because here we have the sofa and the table almost in the center of the room. So it's best if we direct the sun onto the sideboard. It's rendering pretty fast, as you can see, because V-Ray is only rendering the lighting. This way we can find the right light shadow pattern pretty fast. And then once we found it, we turn V-Ray Dome back on. All light sources in our scene have a white neutral color. And our scene looks very much like the reference. To achieve a colder or warmer shade of light, you can do post-correction in the layers. And we do that by adjusting curves or the white balance. And this is how you achieve a warmer or a colder shade, basically. Also, in the exposure settings, you can adjust contrast, you can adjust exposure, and the highlight burn parameter. Adjust it to taste until you get the perfect result, and that's it. Alright, so that's all for this lesson. We'll see you in the next one.